So now that we can identify some insoluble solids using our solubility rules, and for now you can keep referring back to that chart. Eventually you'll have to be able to do these on your own. Let's look at some reactions. So we're going to try to do some double replacement reactions or exchange reactions. And what's happening here is you're going to start off with a cation and an anion, and a cation and an anion, and they will switch places. So A is now going to react with D, partner up with D, and C is going to go with B. So the cations are here. This is basically cation, anion. This is a cation and an anion. Now the cation from the first reaction is going to find the anion of the second reaction, so A and D, and then the cation of the second reactant. I said reaction. So the cation of the first reactant is going to find the anion of the second reactant. The cation of the second reactant is going to find the anion of the first reactant. And so they basically just switch places. So I usually just write down A and C and then flip-flop. Now that's great if it's all 1 to 1 to 1, a +1 and a -1. It gets a little bit trickier when you have different charges. So let's try one of those. So in sample exercise 4.3, they tell you a solid forms when an aqueous solution of barium chloride and potassium sulfate are mixed. Write a chemical equation and identify the precipitate that forms. So these are my two reactants. I have barium chloride reacting with potassium sulfate, and I need to figure out what those reactants are. So usually what I do is I'll write on top here. I know I have, I just split them up into ions. I have barium has a +2 ion charge and chloride has a -1. So remember, barium is a +2 ion, it's in group 2, and the chloride ion over here is in -1. So remember how this goes. Everything in group 1 is +1, +2, and then 1, whoops. Where am I? Oh, there we go. 1, 2, 3. And then working backwards, I got -1, -2, -3. So make sure you remember these charges. So we have barium with a +2 charge. We have the chloride ion with a -1. Potassium has a +1 charge, and sulfate has a -2 charge. So over here on the product side, I'm going to have a barium and potassium. Don't worry about these subscripts yet. We're going to balance these. We're going to write these chemical formulas, and then we'll balance the reaction to get the subscripts out. But really, what does this look like? I have 1 barium ion, I have 2 chloride ions, I have 2 potassium ions, I have 1 sulfate ion. So over here on the right-hand side, I'm going to write barium with a +2 charge, potassium, and then I switch places. Barium is now going to react with the sulfate, potassium is going to go with the chloride ion. So I have a Cl- ion, I have the sulfate. So really, at the first step, you're just writing down the ions, right? And then I'll crisscross and make my formula. So this is BaSO4 because I have a +2 and a -2, and this is potassium chloride. So make sure you don't just carry that subscript over here and say like, oh, K2Cl. That's not what potassium chloride looks like. Potassium has a +1 charge, chloride ion has a -1, so I have 1 to 1. So now I need to balance, right? I have barium chloride, potassium sulfate makes barium sulfate and potassium chloride. I have 2 potassiums. I'm going to put 2 in front of there. I have 2 chlorides, and 1 barium, 1 sulfate. So now I'm good. Now, how do I know which one of these is the solid? So they tell us a precipitate is forming. I know, what do I know? What do I know? I know that potassium is a group 1 metal, right? Potassium is a group 1 metal. Where's potassium? Oh, all the way over here, and then group 1. Right, it's one of the alkali metals, so I know that potassium chloride is going to be aqueous. I know that potassium sulfate is going to be aqueous. They told us in the beginning that barium chloride is aqueous. Remember, chlorides are usually soluble except with silver, lead, and mercury, so that process of elimination is going to tell you that barium sulfate is the solid. Now, if you remember from the solubility rules up above here, sulfates are usually soluble except with strontium, barium, mercury, and lead. So it's one of the exceptions to the sulfates. So sulfates are usually soluble except with barium. So that is our sulfate, which is going to be the solid.